All right, this is nowhere in your packet. Just want to do a 2-minute review of yesterday. 2-minute review. You cannot use Hills and SAS whenever you feel like it. It's got to be a certain diagram. Can anybody explain to me, I have it up on the board up there, the diagram that you need that says ding, ding, ding. Make sure you tell them I said hi on that text message that says I got to use Hills and SAS. Okay, can you tell me the type of diagram that is required before you use Hills and SAS? Go ahead, Anthony.
Right triangle.
Okay, hold on. Whole thing's got to be a right triangle. Whole thing's got to, then I got to draw in what? Drawn to where? Where's AD drawn to? The hypotenuse. That's the diagram I need. We're all good there. That's the first hurdle, is identifying the diagram so I can use Hills and SAS. All right, I'm going to need 3 people right now. 3 people. Name, the first person I call on here, name 2 of the sides up here. What do we call them? All right, what do we call them? Just 2, just 2. Here you go, 13. Name 2 of the sides. Which ones? Okay, CD and BD we call segments. Nice job, Emily. Good start. Name another 2 up here and what we call them. 3. Name another 2. Legs. Nice job. So the last person here has got to name AD and CB for me. AD and CB, what do we call those? Boom, 12. What do we got? It is the altitude. And how about CB? That's the hypotenuse. Perfect. We're all good there. Next thing I need somebody's help with is what the heck does Hills and SAS mean? If I want to use them, got to know what to plug in for them. Okay, here we go. Somebody's going to take Hills for me. 25, want to take Hills here. What's the H? L? L? Same leg. Means are always the same. S? Segment next to or adjacent to the leg I'm using. Great job. And what's the deal with SAS? 26, what's the deal with SAS? Yep. Yep. Other segment. Good. Extremes are different. Means are the same. We're all good. 2-minute review. You ready to go next level now? All right, here you go. Right off the bat. First diagram. Finding X, Y, and Z. Wow. So now, right off the bat, you just don't have one variable like it was nice and cute yesterday. One variable. Now there's 3 you got to solve for. And we have to decide as a class, which one do I have enough information for? Let me do the wrong one first. What's Y in here? What's that segment called? Altitude. So I'm like, boom, I can use SAS. That's what he told me yesterday. Don't copy this down. 100% incorrect. Watch, ready? Name a segment. Name the altitude. Name the other segment. Ha, I ain't solving that. 2 variables, are you kidding me? I'm not solving that. So Y is out of the question. No chance can I solve for Y using SAS. Everyone see Y? See ya. All right. What else you got for me here? Thomas? Hills? Okay, what's the H in Hills stand for? Okay, so what would you label as the hypotenuse here? Okay, 1 plus X. What's the L in Hills? Okay, and I probably want to pick which leg if I'm going to do it. 3, I want a Z, right? So we could go Hills. Okay, that's an option. Everyone see I could do Hills. I'm not going to do it that way because I want to introduce something new now. Not new, but what type of triangles are all 3 of these? Right triangles. Yes, you have Hills, you have SAS, but you have another device that you've known probably since middle school that you can use only on a right triangle. Bella, Pythagorean theorem. Start getting that into your mind now with Hills and SAS today, that you can use Pythagorean theorem. Which triangle can I use it on? This one right here. I can use Pythagorean theorem. So start getting in the mindset now. Hills, SAS, and now today, Oh, maybe Pythag's an option because all three triangles are right triangles. Set it up for me, please. Set it up. 14, set it up for me. What's Pythag going to look like? Define y. 1 squared plus y squared equals, calm down, 3 squared. There we go. And you know what you're leaving your answer in. That's not even a discussion point. Y squared, get everything to one side. Just let me know what y squared is equal to. Don't go ahead of me here. Y squared is going to be equal to what here? Woo! 5, what do you got? Y squared equals 8. And you're darn right, you better be breaking that down, everyone, at this time of the year. Go ahead, break down 8. When you break down 8, let me know. We don't have a 30, right? No. 28? No, look at that. 2 in a row. 29 we do. No. Simplest radical form. Thank you. 2 radical 2. All good. All right, 2 radical 2. Where can I go now? Let's see, what other variable could I now? Oh, what did I just label 2 radical 2? That's the what? Altitude. So we could go what now? Now that I have the altitude. All right, let's do it. Let's set up a little sass here. Define x. Fill it in for me. Here you go, 29. Fill it in. Segment. 1. Altitude. Altitude. Other segment. There we go. That's why we have our calculators. 2 radical 2 times 2 radical 2. Five. What do you got for me? 2 radical 2 times 2 radical 2. 8. 8. We're okay so far. And now we have to find z. And this is what I think is the great part of this. There are 3 different ways you could find z here. 3 different ways. One way I could find it. Pythag, ready? You could do Pythag with this little triangle on the right, or I could do Pythag with the big dog. Everyone see that? I could do Pythag with the large right triangle. So Pythag 2 different ways. What is z here? Is that, what part of the right triangle is that? Leg, so I could also use hills. I could use hills. All right, here's how I'm going to do it. I'm going to use Pythag just so I can show everyone something on the calculator. We're going to use Pythag on this small right triangle to the right. Okay, we're going to use Pythag on that one. And I'll show you why, because there's a little calculator hiccup you may run into. All right, so if I do Pythag on that one, help me out setting it up. 29, set it up for me. 8 squared plus 2 radical 2 squared equals, nice job setting it up, Billy. Here we go now. Obviously, we have 64. Okay, I need everybody's attention here no matter how you did it. When I go right now to do 2 radical 2 squared, take a look at my calculator. Watch. 2 radical 2 squared. I get 4 in this case, but watch what happens now when I put 2 radical 2 in parentheses. Doesn't matter, right? I should get 4 out. No, I don't. What's the calculator doing on this first one? Just squaring Radical 2. What do I need to square? 2 radical 2. So I'm trying to show you if that happens in the future, better put that bad boy in parentheses. Okay, put it in parentheses because the 4 is not the answer I need. It's 8 because I'm squaring the entire thing. So plus 8 equals z squared. Whole thing goes in parentheses. So I get 72. And you better believe that thing's going in simplest radical form. And I'll let you know 9's not the biggest one. That goes into it. There's a bigger perfect square than 9. Break that down for me. 30, yep, great job. 29 again, break that down for me.
6 radical 2.
6 radical 2. Okay, all good, guys? So where do you start? Hills, SAS, now Pythag, wherever you have enough information for. Questions on those? One doesn't make you great. Let's get to another complicated one. Doesn't look like much, right? Solve for X, solve for Y, we're good. And of course, I mean, look, I gave you probably the worst hint in mathematical history. Think of old stuff to get started. That could go a lot of different ways in this class, that's for sure. Some of you are thinking about senior citizens. Some of you maybe moldy bread, whatever old stuff you can think of. Maybe not math. Oh boy. Why can't I eliminate SAS right off the bat? There's nothing about the altitude. Nothing. Here's going to give me a problem. Why? Well, I do know the hypotenuse, but it would be x plus y. And I'm not doing 2 variables. So Hills is a little bit of an issue with that. So SAS is out. Hills isn't going to cut it right now. What's the third thing we just introduced in the last problem? Can I use Pythag somewhere on this diagram? Yes, no? Remember, you got 3 right triangles, the 2 small ones and the large one. Can I use Pythag anywhere? Which triangle? One of the 2 small ones or the large one? Fiona, what's up? The large one. Yes, you can. You can use Pythag on the large one to find the hypotenuse length here. All right, so let's do that. That was my old stuff to get you started. My hint was use Pythag. 26, set it up. Whoa, I don't want to do x plus y, Jack. That's going to make fits for me. Just c squared. I just want to find the whole thing. Okay, everyone else all right? I don't want to try to introduce 2 variables. I'm finding the whole thing right now. All right, go ahead. There should be no breaking down here. You should just get a perfect square at the end that you can take the square root of. And what's the length of that entire hypotenuse now? 19, entire hypotenuse. 25, nice job. This whole thing's 25. And that helps me now because what can I now use? Hills, which I couldn't before because I didn't have the actual hypotenuse length. So now I can use Hills. All right, we'll see who's on their toes on this one now. Love it. 3. Here we go. Am I ready? On your toes. Hypotenuse. Just found it. Leg. Okay, she could have picked 22. All right, she chose 15. I'm going with it. Leg. Same leg in Hills, right? Same leg. Means are the same. Now, if you chose 15, you have to choose what variable now for your segment? X, YX, and not Y. It's the one adjacent. Okay? If you pick 20, she would have picked Y instead. All right? 25x equals 225. And the value of that segment, x, bless you, 6. What do you got for me? X equals 9. Nice job. Okay, you can use hills again, but is there a really, really, really quicker way instead of using hills again to find y? The whole hypotenuse is how long? 25, and I already know one of the segments is 9, so subtract that, and y is going to be 16. All right, so hills, SAS, Pythag. You got to start somewhere. All right, you should not have a problem in front of you where you can't use any of those. All right, next thing is real quickly, we can apply it to a word problem. I know it's pretty cheesy, the word problem, but I just want to show you that we can apply it to a word problem. How about this photographer, everybody? Wants to take a picture of the beachfront. Yep. His camera's at a 90-degree angle. Perfect. He's got to get the 2 palm trees in there. That's clutch. At points A and B, those palm trees got to be in the photo. Makes it look a heck of a lot better. So he's going to go on a walkway that goes over the ocean. His camera has a viewing angle of 90 degrees. What distance down the walkway should he stop to take his photograph? So looking for the walkway here. What is the walkway acting as in that diagram? 1. That's the altitude. So Matt, if I need to find the altitude, I should probably use what device? SAS. Here we go, everybody. Just trying to show you we can use it in a word problem too. Who's going to help me fill it in? 20. We have a 20. Claudia, go right ahead. Segment. Altitude. Altitude. And segment. Good. Nice job. $16. X squared equals 3,600. How far on the walkway does he have to go? I got a 16. Whenever you're ready, Thomas. 600? Oh, that's a long walkway. 60 what? Bananas, chairs, corn shackles? What do you got? Feet. Good. Any questions? Might be tough to start somewhere. You can do it in a word problem. Last thing, what happens if the proportion's easy to set up, but the algebra's not? Ready? Here we go. And we know this is a killer for some of you, unfortunately. That's why we need to go over it. There you go. Look, solve for x. I think hopefully most of us right now know what to get. Know what device to use out of Hills, SAS, and Pythag. 26. What do we want to use? Where? What are you going to do? 10 squared? I'm waiting for the rest. Okay, that actually might be a better idea. Yep. Because I was wondering where you're going to go with the old Pythag there. Okay, yep, SAS, good, a great option. Only option. 8. 21, want to fill it in for me? It's quite all right. Segment. Altitude. Altitude. Segment. All right. Very easy setup. And here you go. It's been holding some of you back for the last month. Cross multiply for me. 26. Oh, here we go, Jack. Come on. Rough day today for you. Redeem yourself right now. I just want you to cross multiply and tell me. Okay, we got 1/2 of it right. Equals Okay, thank you. You're good. Redeemed. We spent a whole darn unit on this. Let's go. Let's go. We spent a whole unit here. 12. Next step. Here we go. For time's sake and the level of math we're in here, we're not doing quadratic formula right now. If you want to do that tonight on homework and on quiz and test day, go. Not right now, though. Two numbers that multiply to what? Negative 100. And add to, let's go. Don't yell it out. I want you to try to find it on your own, please. Multiply to 100, add to 15 somehow. Come on, let's go. Dig deep. Can't let you go to Algebra 2 next year. When you have those numbers, let me know. Let's go, 26. You of all people should be getting this. Yeah, all right? After where you come from. Yeah, you are darn right you did. There you go. 20 and 5, negative 5. Everyone good? From here, my two answers. 22, my two answers. 5 and negative 20. Anybody want to talk to me? Problem? Bella, problem? Settle down. Negative side. Oh, discipline. Look, what did I ask you for? Go back, look. What did I ask for? Oh, there we go. Everyone all right? A little factory in there? All right, one more to seal the deal. All right, here we go. Right away, what's the 12 labeled as? Altitude, so it looks like a little sass here. All right, a little help. Some of you are running into a problem now. 18, can I get a little help? Segment, that's labeled. X, altitude. Altitude. Woo! And then we come to this unlabeled segment that's got to go in that proportion. It might be unlabeled now, but you can label it yourself. How long is the entire hypotenuse? 26. That segment is X. Bella, continue. How would you like to label the other segment? Ooh, 26, the larger one minus X. Everyone see that? The hypotenuse minus that segment, 26 minus X. So it is possible even though it's not labeled. Are we all right on that one there? Getting that extra segment in there. All right, cross multiply time. 26. I don't pick them, Jack. I just press the button. Yep. Okay, 26x minus x squared. Yeah, it would be real easy just to move that 144 over, wouldn't it, and go, but you would still run into a problem. What do we hate in here? Negative x squared. So can we just bring everything to the left? How do I bring that negative x squared over? Add it. How do you bring the 26x over? Subtract it. I didn't move the 144, so that stays positive. And yes, time's sake and the level of math. Two numbers that multiply to what? 144 and add to. Don't start whining because 144 is a large number. Find it. Find it. Find a way. Let's go. Find a way. Don't whine about it. Find a way. Multiply to 144, but I'm going to give you a negative 26x. What is it? Find those numbers. 28. We don't have one. 24. We have one. Good job. Negative 18 and negative 8. Your two answers come out to be 9. What are my two answers? X equals 8 and 18. All right. Rejection? Rejection? Plug them both in. Are they going to give you a positive side length for X? Okay, so here's a different opportunity where I don't reject anything. I actually keep both. It could be 18 or it could be 8. Get rolling. Let's go. Get rolling. Please pay attention to the problems tonight because some I said simplest radical form, and that's all I said. All right, never mind. So just simplest radical form if necessary on a few of them. Let's get rolling.